Hello, hello, hello. So we have come over here with another live session. So it's a lazy Saturday, I know. So learning should never stop, as I always tell you. And whoever is attending this live session, I'd like to thank you in advance that all of you have decided to spend 1 hour of your quality time with me for this live session. I appreciate that a lot. Now, before we start off, just give me a quick confirmation if you can hear me and if you can see me. So I see there are 8 people as of now. So if all of you could, give me a confirmation on the chat, I can proceed with the session. Now, in the meanwhile, I'd like to tell you about this platform called as Great Learning Academy. So you've heard of Great Learning. What exactly is Great Learning Academy? So Great Learning Academy is a free initiative by Great Learning, and over here you would get all of the free courses with respect to different domains. So if you'd want to learn machine learning, AI, cloud computing, big data, digital marketing, so whatever is the field that you'd want to upskill in, we've got a course for you. And the best part is once you complete any of this course, you'll get a course completion certificate. And you can go ahead and add that certificate onto your resume or onto your LinkedIn page, and that would be a huge value add to you folks. So the link for Great Learning Academy would be available to you in the chat. So someone from my team would be putting up the link over here. So you can directly go ahead and check out Great Learning Academy from here. And now let's say if you do not have your laptop with you or even a desktop with you, well, we've got you covered. We also have the Great Learning app. So you can directly download the Great Learning app on your mobile, and you can start learning all of these courses on the Great Learning app as well. So the link for the app would also be available to you in the chat. So you can also check out our app over there. So quickly, I see that there's a watching of 29 and we've got only 6 likes. So if all of you could hit the like button, that would be amazing. And to the folks who are new to our channel, if you haven't yet subscribed to our channel and if you haven't yet clicked the bell icon, well, go ahead, hit the subscribe button, hit the bell icon, then we would appreciate that a lot. So on that note, we will start off with today's session. So what do we have in store for you guys? Well, mathematics. Before I start off with mathematics, I'd like to know how many of you like mathematics and how many of you are scared of mathematics. And some of you might like mathematics and even, you might like mathematics, but then again, you might be a bit scared of maths. So let me know in the chat if you love math, if you're scared of math, if you want to learn math because you're scared of it, or whatever is your relationship with this field called as maths. Let me know. Well, I personally have, let's say, a very complicated relationship with maths because it's something which has always scared me, but since it scares me, I'd want to become better at it. So that's my relationship with maths. And whenever it comes to this field of data science, mathematics plays a very vital role. So if you want to be a good data scientist, then you cannot be a good data scientist without good mathematics, right? So mathematics is one of the pillars that supports data science, and you have to be really, really good in this field. So I'm just going through the chat over here. Pre-Tech Education says, yes sir, I like so much. Kashyap Pandu says, I do. Manoj Kumar says, love. Ankit says, kind of. Yep, kind of. Well, with math, you always have a love-hate relationship. I'm pretty sure no one has, a pure, unselfish love towards math because let's be honest, mathematics isn't always, so caring towards you. So yeah, it's always a love-hate relationship towards this field called as mathematics. Amit is being extremely honest. He says, I do not love math. Well, I appreciate the honesty, Amit. So in this session, whether you love math, hate math, or you're sort of apathetic towards this field of mathematics, well, whatever the situation is, today we will be looking at some of the important mathematical concepts that are important for this field. So let's get started. Now, what are the key takeaways today? So since we are dealing with mathematics for data science, first we'd have to understand what exactly is the data science life cycle. And in this data science life cycle, we'll understand where exactly math fits in. So if understood that this is math related to data science, but your first question would be, where is it that I would have to apply mathematics in data science? And that is something which we'll understand, and then we'll proceed towards learning all of the mathematical concepts. So once we look at the data science life cycle, we'll look at two important mathematical concepts, which are statistics and probability, which are the two core components of this amazing field of data science. Now that is set, in this session, my first question is, what exactly is data? Well, the answer is written right in front of you. It's collection of facts. Now, when I say fact, it is not exactly information. This is a raw fact. And raw fact would be, let's say, Joey loves pizza, right? Joey loves pizza, that is a raw fact. But what information does it provide you? Does it tell you that Joey also loves pasta? No, it doesn't tell you anything. Does it tell you that Joey hates burger? No, it doesn't tell you that. So Joey loves pizza only tells you Joey loves pizza, nothing more than that. So now, when you have all of this raw data with you, what are you actually doing with it? You don't have any other, you don't have conclusive insights from the data. So that is the problem with it. And also, whenever we talk about data, data can be present in any format. So data can be numeric numbers such as 23, 8,000, 10,000. So all of these raw numerical numbers, these also constitute data. And when I use statements such as Joey loves pizza, this is Sparta, or I don't know, Wingardium Leviosa, that again is just data which doesn't really provide you any insight. Now, it's again not necessary that data should only be present in the form of numbers or statements. Data can also be present in the form of images and also videos. And especially after the internet boom, after the social media boom, you have a lot of data which is present in the form of images and videos. So every single day you have a lot of people uploading their photos on Facebook as well as Instagram. Similarly, you have lakhs of people uploading videos on YouTube and other streaming services. So all of this is nothing but data. But again, as I tell you, this is just raw data. Now, until and unless you are finding insights from it, it is not useful. So this is where information comes in, and this is where data science comes in. So now you have the raw data. So as you see, 1,000 units of television X sold in the month of January. So if I just only tell you 1,000 units of television X, that is data. But I am giving you a piece of information over here. So in the last month of January, let's say it was some electronics brand. It could be any electronics brand, and they sold 1,000 units of television X. This is a piece of information. Now this tells you something very important. So these are the sort of insights that we need from raw data, and this you will be able to find out with mathematics. So now that this is clear, let's look at the data science life cycle. So in the data science life cycle, first we will be given the problem statement. Now, it's not as if you randomly, would pick up a machine learning model and think that, I'm just sitting idle today. Today is a Saturday afternoon. Why don't I just randomly build an ML model on a random data set? That is not how you go about it. So what happens is, normally you would be given a problem statement. So when you're working as a data scientist or when you're working as a machine learning engineer, you'll be provided with a problem statement. That problem statement would be given by your client or could be an internal problem which would be solving for your company. So now once you're given the problem statement, you would also be given what are the required factors to solve the problem statement and from where can you possibly get the data. So once you have the problem statement, the next step needs to be to collect the data. So now when I told you that data is present in a lot of formats and data comes from multiple sources, your step here needs to be to acquire the data from multiple sources, and also you have to understand that this data is present in multiple formats. So you are getting this data from multiple sources and multiple formats, and you'd have to integrate this in one singular format. So this is the data acquisition phase. So you collect all of this data, and let's say you store that in a central storage repository. Let's call that central storage repository to be a data warehouse. So you have stored all of your data in this data warehouse. Now, after that, what are you going to do? After storing the data, I've told you that this data has to be integrated or put into a proper place. So just give me a second. I'm getting a call. I'll just ignore that. Yeah, sorry for that. Yeah. So now once you acquire the data, so once you acquire the data, this data is again very raw. So as I've told you, you only have raw data, you'd have to convert that into information. So how do you convert that into information? Well, this is where pre-processing and EDA comes in. So now in your raw data, there could be a lot of problems. It could have missing values. It could have a lot of anomalies. It could have, there could be some of the data could be extremely incorrect. So these are the problems which your data might have. So you'd have to pre-process this. You'd have to remove all of them. You'd have to remove all of the anomalies. So wherever there are missing values, you'd have to either remove that complete row or you'd have to impute them with some other values. So these are some things which you do in your EDA stage. And in your EDA stage, this is where your basic math, your statistics and probability comes in. So when you're trying to understand the data, also understand this term properly, exploratory data analysis. So you are exploring the data which you have with you, right? So you have a data set, and if you have to understand the data which is present in front of you, and also remember that if you have a normal Excel sheet, in that Excel sheet, most of the data would be present in the form of numbers or text. And if the data is present in the form of numbers or text, math is the best solution towards that. And this is where stats and probability comes in. So your EDA stage and your data acquisition and pre-processing stage, this is where your stats and probability comes in. Now, once you've got your tidy data from your raw data, on top of this, depending on the problem statement, you'll build an ML model. Now, again, in the ML, when you're building the ML model, all of your machine learning models are also based on a mathematical principle. So here as well, you would also need a lot of mathematics. So again, you'd have to be good with mathematical concepts such as linear algebra, matrix calculation. You'd have to be good with differential calculus as well as integral calculus. Now, once you apply your ML model, you'll get a result, and you have to go ahead and deploy that result on some cloud service. So this is your entire data science lifecycle. So now we are done with this life cycle. So this is the entire life cycle, and so we've basically understood what are we supposed to do from when we've got the problem statement till we are supposed to deploy the model, and we've understood where exactly math comes in. So we'll go ahead and look at some of the statistical concepts. So first, what exactly is statistics and why do we need statistics? Well, the answer is very simple. Whenever you're dealing with data, and let's say whenever you're dealing with an Excel sheet, it has a lot of numbers in it and it has a lot of text in it. And when you're dealing with a lot of numbers and a lot of text, statistics is the best way to deal with it. And you're able to understand the underlying structure of the data. Right? You're given raw data, and if you're supposed to understand the underlying structure of the data, you would need statistics over here. So this is very clear. Now, we have two things over here. One is known as a population, another thing is known as a sample. So whenever you are given a problem statement, so let's say the problem statement is this. I want to know that if there's a direct correlation between smoking and getting cancer. So let's say I come with the statement, whoever smokes will get cancer. Or let's make it even more specific. Whoever smokes get throat cancer, right? So I'm making this statement over here. Now, if I have to verify this statement, I would have to maybe conduct an experiment. I would have to do a survey. And so I have, so let's say now when I do this survey, I have this entire population over here. So if I just talk about India's population, that's in billions. So what I do is, let's say right now I'm in the city of Hyderabad in India, and I just want to perform this simple survey on not just everyone in Hyderabad, let's say the people who are currently near my area, right? So let's say I go to every single house who's there in my area, and I want to know how many of them have a history of smoking and how many of them in their family have been diagnosed with cancer, right? So I possibly make two columns over here. One, if that person smokes or not. Two, if that person has cancer, right? So here the people I survey is known as the entire population, right? So this is my population for the experiment. Now I have all of this data with me. So again, you have to understand, right? So when I say population, this population, what I'm trying to do is this population, the population of my area, I would try to extrapolate it to maybe our entire country or maybe to the entire world. Because my statement, what is my statement? My statement is smoking causes cancer. And if I have to prove this statement, right now my population is very small. My population is only those people who are currently in my area in Hyderabad. So maybe let's say I survey around 200 odd people in my area, right? And I have two columns for these 200 odd people, and I would try to extrapolate this to everyone in the world. So this is how normally your data science experiments go. So I've collected this population. Now again, here what you do is, since you have a very large population, uh, you know, probably maybe building a model on this entire population or getting inference or getting all of the factors from everyone would be very difficult. So what I do is, again, I take a sample from this population. So as I've told you, I am only surveying the people in my neighborhood. So the people in my neighborhood would become the sample of the entire population of this planet Earth, or maybe let's say this entire country. So people in my area would become the sample and everyone else would become the large population. So this is what is known as population and sample. So now that we are clear with this, we are supposed to understand some details about our samples. And to understand these details, we have something called as parameters. And when it comes to parameters, we basically have measures of central tendency and measures of deviation. So I believe all of you have heard of measures of central tendency. So we have mean, median, and mode. So you would have learnt about these in your high school or maybe in your primary school itself. So let's understand each of these over here. Now, what I'll do is, before I actually go ahead, let me quickly go through the chat and see if there are any more questions. So I don't see any questions over here. So if you have any questions, keep putting them up in the chat. I would love to take them up. Right. So anyhow, I see that there's a watching of 77 and we've got only 53 likes. So if all of you could quickly hit that like button, that would be amazing. And also, if you haven't yet subscribed, hit the subscribe button and also hit the bell icon. That would be great as well. So yeah, keep putting up your questions. I'll take up your questions in a while. Now to continue, measures of central tendency. Now, if we have our sample, now we are supposed to understand what that sample describes. So let's say if there are 60 students in a classroom and I want to know what is the intelligence of all of the students in this classroom. right? So 60 students, well, that might be small. Let me actually increase the sample space. So let's say if there's a college, let's call this college, I don't know, let's call this college XYZ, right? XYZ College of Engineering. Now, I want to know what is the average intelligence, or what is the intelligence of every student in this college, XYZ College of Engineering. Now, how do I do it? Well, the best answer would be to take the mean, the average intelligence. So let's say if all of them were to give an IQ test and maybe they would get a score of 100, let's say, in the IQ test. Now, what I'm basically trying to say is there would be some people who would be getting less than 100, there'd be some people who would be getting more than 100, and everything averages out. So, on an average, you can say that. So, let's say if there are around 1,000 students in a particular university or in a particular engineering college, then for these 1,000 students, the average intelligence would be around the IQ of 100. So, to describe a common point, now if you have a population and if you have to describe that entire population with one parameter, this is where you would need these measures of central tendency such as mean, median, and mode. Right? So, I've given you one example where the average intelligence could be one particular case. Now, similarly, let's say we have another case which is median. Now, median would again, so let's say if I take a class of 100 students and if I want to find out what is the height of everyone in that particular classroom. Now, what I can do is I could make everyone stand in ascending order of height or descending order of height and take the middle person over there exactly. So the middle person over there would probably tell me the height students whose weight is 90 would represent the weight of the class. Now the others, there could be a student whose weight is only 45, or there could be another student whose weight is probably 200 kgs, right? But since a lot of people or a lot of students whose weight is only 90 kgs, that is why this 90 would be my representative over here. So this is how mean, median, and modes work. So I hope this is clear. So we'll look at all of these individually as well. Nanika is asking, do you have a course on statistics and data science? Yes, Nanika, we actually do. And so here, as you see, this is Great Learning Academy again, and I have gone onto this tab of data science. And here, as you see, we have got a course called as Statistical Methods for Decision Making. Similarly, we have got another course called as Probability for Data Science. So if you'd want to learn statistics or probability for data science, head over here and you can register for these courses. That would be amazing. Suryakant is asking, why don't you take a full series on statistics and probability? Well, we actually have that in mind. So sure, we might probably take a live session soon on statistics. So today's session is also more on statistics and probability, and we might do this as an entire series, or we might upload a full course on statistics and probability. So that is something which is on our mind right now. Omkar is asking how it is needed in data science field. Well, as I've told you, statistics and probability form the core of data science. Since you're dealing with data, so there are some things which we'll actually understand over here. So let's say normally whenever you have to build a model, you have to ensure that your data is normally distributed, right? So this is a very important term in data science, normal distribution. So normal distribution means that your data is in the form of a bell curve. I'll just show that to you. Let me go ahead over here. Let me go a bit up. So what I mean by normal distribution is your data would be present in the form of a bell curve. And if your data is in the form of a bell curve, your mean, median, and mode would be equal. So this value which you see, this is where your mean will be, this is where your mode will be, and this is where your median will be. Right? And normally, whenever we are building any of our ML models, it is important that we convert our untidy data into a normal distribution or into a bell curve. Now, also, as I've given you certain examples, so let's say if I have a bunch of students in my class and if I make them stand, right, it could be height wise or it could be any other criteria, there you would see that a lot of people would have the same height, isn't it? Right? So a lot of people would have the same height and they would represent your they would represent your your center of your entire class, right? So let's say if there are 60 students, out of those 60 students there might be around 35 odd students whose height might be around, let's say, 5'6" to 5'9", right? So there might be around 35 students whose height is around 5'6" to 5'9", and the majority of them would be around the center. And there'd be very few students whose height is, let's say, around 5'1", 5'2", or 5'3", and there'd be very few students whose height is higher than 6. So those few students would come at the fag end of this bell curve. So whatever real world example you take, most of your data is present in the form of a bell curve. And this is what we call as a normal distribution. And that is why it is extremely important. Again, we'll understand more about this as we'll proceed. So for now, we have other things to cover. So we have some basic stuff to cover, which is mean, median, and mode. First, we'll cover this, and then we'll head to normal distribution as well. Roshan is asking, does a data scientist need to be better at statistics than a software engineer and better at software engineering than a statistician? Well, I'll make it extremely simple. So if it depends on the field which you want to get into. If you want to enter the field of data science, the answer is very simple. You have to be good at stats and probability. There is no other way around it, right? You cannot escape mathematics. This is not as if you have some other option over here. Like I leave this, I learn something else. That is not what happens if you want to enter into the field of data science. Because language is something which is easy to pick up. Math and statistics is where most of the people have a problem with. So this is something which you have to brush up if you are probably if you probably are weak at this side. At programming, if you know one programming language, it is extremely easy to pick up another programming language. So I'd suggest you, if you want to enter into the field of data science, I'd suggest you to focus on more of stats and probability. On the other hand, if you want to enter into the field of software development engineering, so in the field of SDE, you would have to focus more on data structures and algorithms. Here again, focusing on one language is not important, because if you know one language, again, picking up another language is extremely easy. So here what you'd have to do is focus on DS and Dalgo. Learn about time complexity, space complexity, understand whatever algorithm which you build, how can you improve the time complexity of it, how can you improve the space complexity of it. So these are the things which are asked in those whiteboard coding interviews. So decide in which field you'd want to enter, and depending on that, you can focus on focus on how you'd want to go about with it. Right. So I have taken enough questions again, and I will head back to our session. Right. So first we have mean. So mean, as I have told you, it is the it would tell you the average of your entire population or your entire sample. And to calculate mean, it's extremely simple. So we have this very simple question over here. We have been given 5 numbers and we are supposed to find out the arithmetic mean of these 5 numbers. Well, the answer is extremely simple. It would be addition or summation of all of these 5 numbers divided by 5. Right, while I'm calculating this, I would also give you a minute to solve this. So I'll quickly open up my calculator over here and I will get to the answer. So in the meanwhile, you can also perform this. You can see these numbers over here. So it is 565 plus 570 plus 572, then you have 568 and plus 585. So now this is the total. Now this you would have to divide with the numbers, with the quantity. What is the quantity over here? It is 5. So divided by 5. So the answer of this is 572. So the mean of these numbers would be equal to 572. So I hope most of you were able to get the answer in the chat. So quickly let me know if you're following me till here. Again, nothing complicated over here. So next up we have median. So median, as I have told you, median would be the middle value. But then again, if you are supposed to find out the middle value, these numbers must be arranged in ascending or descending order, right? So again, I want this session to be very interactive, folks. So while I'm solving this, I want you guys to solve this as well, right? So quickly, if if anyone of you knows the answer, quickly put them up in the chat. I want suggestions as well. So now, as I've told you, this has to be arranged in ascending or descending order. So what I'll do is I'll take up another text box over here. I'll put the text box. So what is the lowest value? It is 40. Then we have 45. Let me write it down. After 45, it is 55. Let me write down 55 as well. After 55, we have 60. After 60, we have 65. Going ahead, we have 80. And finally, we have 90. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 7 numbers. So what is the middle number over here? So this 60, as you see, is the middle number out of all of these numbers. So 60 is the median or representative of these numbers. Crazy Tech World is saying 60, Nainika is saying 60, great. So I hope all of you are able to find the answer. So we have understood mean, we have understood median. Next we will proceed and go for mode. Mrinalini is saying 68.27% of data lies within one standard deviation of the mean. Yes, that is absolutely right. So Mrinalini, well, we'd have to wait for another 5 minutes to get to the normal distribution and empirical rule. So a lot of people would not know what exactly is normal distribution and what exactly is empirical rule. Let's just wait for 5 minutes. Let's complete our topics over here and then we'll head to empirical rule as well. Next up we have mode. So when it comes to mode, as I've told you, mode represents that particular value which has the maximum frequency. So again, I would want answers in the chat section. So someone in the chat has already answered as 340. Let's just verify if it is correct or wrong. What I'll do is I'll quickly make up another text box over here. Let's see how many 340s are there. So we have 1, 2, 3, 4 and 5. So 340 is occurring 5 times. Next up we have 350, which is occurring twice. So obviously 350 is not the answer. Then we have 330. Let's check 330. 330 I have once and twice. That is also not the answer. You have 320. That is also not the answer. So it is very clear that the value with the highest frequency is 340. And that is why 340 would be the representative of this group. And this representative is known as the mode. Great. So I see that a lot of you folks have got the right answer, which is awesome. So Thomas Shelby is asking, which book should I prefer for statistics? So there's this book called as Business Statistics, which is by Professor P.K. Vishwanath. So PK Vishwanath is also one of the best statistics academicians in India. So he has been actually regularly listed as among the best statistics professors by popular magazine, by popular data analytics magazine. So you can definitely go ahead and check him out. And also, as I've been telling you over here, so this course, Statistical Methods for Decision Making, this course has been curated by PK Sarkar, if I'm not wrong. So as you see, you can just go ahead and learn all of the concepts from this amazing professor. So now that we have understood all of the measures of central tendency, let's understand about measures of spread. Now again, I have a simple question. Why do we need measures of deviation or measures of spread? Can someone tell me in the chat, since we already have mean, median and mode, why do we need measures of spread, and what is it that measures of spread help us with? And this is just a very generic definition or just a very generic answer. I don't want this. So in the chat, let me know, why do we need spread or why do we need measures of deviation? So I'm just waiting for a couple of minutes for you guys to answer. And in the meanwhile, again, if you folks haven't yet liked the video, please go ahead and like it right now, as if you like the video, more people would be notified about this session and they can join this session right now. Also, if you haven't yet subscribed, please do hit the subscribe button, and if you haven't yet clicked the bell icon, also hit the bell icon. That would be awesome as well. Folks, I need answers. I do not see anyone putting up answers. So I have one answer from Crazy Tech World. Crazy Tech World is saying to know the variation in the data. Well, that's a decent enough answer. I want more answers. So Omkar is saying measures of spread as for how many percentage error is there in the data. That's also a reasonable answer. Good. Saptarshi is saying to find outliers. That's also a great answer. Okay. Well, measures of spread. Thomas Shelby saying for dispersion. Oh, by the way, Thomas Shelby, I'm a great fan of your show. So I've been watching Peaky Blinders since the last 3 years, if I'm not wrong. So a big fan of you, so Thomas Shelby. So yeah, as I was saying, yeah, measures of spread. Right. Now let me give you an example. Right, if again we take the same example of students with heights, right, and if I pick average height, the problem with average height is I wouldn't know anything about the person who has the minimum height, or I wouldn't know anything about the person who has the maximum height, right? So you do not know about the end spectrums of it. Now, if you want to know about the end spectrums or how diverse is the data, how varied is the data, this is where you would need measures of spread, right? So measures of central tendency would tell you about how your data is centered or what is the representative of your data. But as someone had said in the data, if there are outliers in the data, or if maybe there is a very low value, or if there is a very high value, I wouldn't have any idea about these low values or high values or end values. And this is where I would need measures of spread. So we have a lot of measures of spread over here, and we will understand each of them properly. So the first measure of spread is range, and range is extremely simple. So range is known as the highest value minus the lowest value. So the difference between the highest value and the lowest value is known as the range. And here we have got a very simple question. So we've been given this list of numbers and we are supposed to find out the range. So now to find out the range, again remember it is the highest value minus the lowest value. It is not the first value minus the last value. So here, what is the highest value? The highest value is 18. So again, let me take up a text box over here and let me write down 18, and let me also check what is the lowest value. The lowest value over here is 9. So here you see your range is 9. So what does this particular value tell you, right? This range would tell you that the spread of your data. So from your minimum value to your highest value, there are 9 other possible values, right? So this is your range. This is how diverse your data is. So these are things which only measures or spread can tell you. Right. Now after range we have something called as interquartile range. Now can anyone tell me why do we need interquartile range if we already have range? So anyone in the chat, we've got the definition over here, but I do want to know what is the requirement of interquartile range. So quick answers in the chat would be awesome. Again, I'm waiting for a couple of minutes for you folks to answer. So why do we need interquartile range? Also, let me know how many of you know what exactly is interquartile range. So as it is stated over here, it is the range. Sorry, as I was saying, it is the range of middle 50% values. But why do we need it? I'll again give you a clue. There is a problem with range. Since there is a problem with range, that is why we need interquartile range. Anyone? Again, I don't see any answers over here. Crazy Tech World is saying don't know. Others? We've got 73 people watching this session and no answers. Saptarshi is saying to find the in-between range, like the first 25%, next 50%. Again, why do we need that? Why are we computing this? The measures of central tendencies indicate the general magnitude of the data and locate only the center of distribution of measures. Yes, that's right, Pranalini. Hiroshi Fernando is saying to avoid the outliers. Exactly. That is the reason. So over here, Hiroshi Fernando has given the exact reason of why do we need interquartile range, to avoid the outliers. So Supriya has also answered it, to overcome outliers. Right. Now I'll give you a very interesting example over here again. So let's say if there's a pub, let's just call it Rich People Club, or actually Poor People Club, right? And the average salary of those who go to this pub, let's say it's around I don't know, it's around 3 lakhs per year, right? I just call it 3 lakhs per year. And one fine day, suddenly Bill Gates decides to come to this pub. Or let's leave out Bill Gates. Let's say Mukesh Ambani decides to visit this pub. So now what happens over here is Mukesh Ambani is an outlier. So because of Mukesh Ambani, your range will totally tilt, or your average will totally tilt. So if you remove out Mukesh Ambani from the equation, the average salary of those who go to the pub is around 3 lakhs per annum. But since Mukesh Ambani decided to go to that pub on that particular night, the average salary would probably increase from 3 lakhs per annum to I don't know, 1 crore per annum. I'm not really sure how much Mukesh Ambani earns, but let's just say it's since there are a lot of other people, let's keep the average at 1 crore per annum. So here, because of outliers, your values could tilt. And this is why, if you have to understand the range, it is important to remove your bottom 25% and your higher 25%. When you remove the bottom 25% and the higher 25% of the observations, what you're left with is the middle 50% observations. And the range between these middle 50% observations is known as the interquartile range. So here, as you see, Q3 minus Q1. Q1 over here represents 25th percentile and Q3 over here represents 75th percentile. So 75th percentile minus 25th percentile. So understand how I'm saying percentile and not percent, right? So 75 percentile minus 25 percentile would be your interquartile range. And then we've been given this question. So let's again understand what is the answer over here. So again, let me quickly take up a text box over here. Let me just solve it right over here. So again, whoever knows how to compute the interquartile range for this, I would quickly need the answers. So if you know how to solve this, put your answers in the chat. Till then, I'll be solving this. So again, if we are supposed to find out the interquartile range, we have to arrange them in ascending or descending order. So here, what is the lowest number? We've got 9. After that, we have got 10.5. After 10.5, let me also keep marking each of them so that I do not forget. 9 is done. Seems like this is taking a lot of time. Right, so 10.5 would also be done. Let me mark it red. After this, I've got 11. Let me write down 11 over here. Let me also mark this as red. Now, after this, I've got two 12s. So I'll have, let me write this properly. I'll have one 12 over here. I'll have another 12 as well. Let me mark both of these 12s. Let me mark this red. Let me mark this red as well. Seems like I've got two 11s as well. I've missed out on one 11. Let me also write down another 11 over here and let me also mark this as red. After this, I've been left with two 14s. So let me write down 14 and 14 over here. Let me mark them red too. This is marked red, this is marked red, and the final number which I'm left with is 18. So here what I'll do is I will also write down 18. Now I've listed all of these in ascending order. Let me see how many numbers are there. 1, 2, 3, 4, 5, 6, 7, 8, 9. So what is the middle value? 1, 2, 3, 4, 5. This is the middle value. Now this is the median. This is the 50 percentile. I am supposed to find out Q1 and Q3 as well. So how am I supposed to do that? Well, let me add two separations over here, right? So this entire part would become one entity and this entire part would become another entity. And now what I'll do is I will find out the median for this part on the left side. So the median on the part of the left side would be my Q1. So what is the median of this? The median of this would be 11 plus 10.5 divided by 2. Let me quickly open up a calculator over here as well. So that would be 11 plus 10.5. What is that equal to? Well, that's equal to 21.5. Let's also divide that by 2. And that would be equal to 10.75. So here Q1, I'll probably add another text box over here. We've got too many text boxes. So Q1 is equal to 10.75. This is fine. After this, we've got all of these numbers. So here, what is the median of this? So here the median would be 14 absolutely. So let me write down Q3 is equal to 14. Now the interquartile range, as we all know, it is Q3 minus Q1. So 14 minus 10.75, that is equal to 4.25. So the interquartile range for all of these numbers would be equal to 4.25. So this would be our final answer. So how many of you have got the correct answer over here? So seems like no one was able to put out the correct answer till now. So just give me a quick confirmation if you were able to understand how did we calculate Q3 minus Q1. Right, that's 3.25. Sorry. So 14 minus 10.75 is 3.25. So seems like I need to get better at my basic calculations. Thanks for pointing that out, Crazy Tech World. So give me a quick confirmation if you were able to follow how to calculate interquartile range. A quick confirmation, please. I'm just waiting for you folks. Yes, 3.25, 3.25, 3, 4.25. Okay, great. So we have calculated interquartile range. We are actually left with a lot of topics to cover for today. So what we'll do is we will see how many topics can we probably cover today. So interquartile range is done, and after this we are left with box plot. What exactly is a box plot? Well, if you have attended any of my earlier sessions on visualization, we would have built a box plot with probably ggplot2 in R or matplotlib in Python. But what does this geometry actually tell you? It gives you a 5-number summary, right? So this, which you see, these ends are known as whiskers. So this gives you the minimum value, this gives you the maximum value, this tells you the 50th percentile, this tells you the 25th percentile, and this tells you the 75th percentile, right? So this is the entire 5-number summary. So if you subtract this value from this value, you will get your interquartile range, because this is Q3 and this is Q1. What we'll do is, let me actually quickly give you an example of a box plot and you'll be able to relate better with this. Let me quickly open up our studio over here. So this might probably take a minute or two. Cyberworld is saying I dislike your video. Not really a problem, but then again, we appreciate your opinion. Thank you also for letting us know. So here, as I was saying, I was supposed to show you a box plot. Now to create a box plot, I would need this library called as ggplot2. I will load up this library of ggplot2, and with the help of this library, I'm going to make a box plot. So here, what I am going to do is, let's say if let me actually take a data set where I have numerical entries as well as categorical entries. That would be better. So let me open up my iris dataset over here. Let me type in view of iris, and over here you would see that I have numerical entries as well as categorical entries. ggplot data is equal to iris and aesthetic x is equal to, let me just write down sepal.length over here. X actually has to be categorical. Let me make that species. Y, let me make it to be sepal.length, and let me add in a geometry over here, geom box plot, and let's see what do we get. So okay, this is not really what we'd want. Species is, let me, or probably maybe I would have to work with some other data set. Let me see if I have the churn data set over here. View of churn. Let me just load that up right now. Just give me a second. This is my folder over here. I have the churn data set. Let me just copy the file location from over here. I'll copy this entire thing. I'll use read.csv, put in the path over here. Let me properly add the path. and I'll go ahead and store it in a new object, call it as churn. Why do we have permission denied? Because I haven't given the name of the file. So churn.csv, let me check if this is right. Yes. Right, so we have loaded this file whose name is churn, and here we've got certain categorical values and certain numerical values. So what I want to do right now is I would want to map a categorical column onto the x-axis. So here, as you see, we've got this categorical column which is internet service, and I would be mapping that column over here. After this, I would need a numerical column, so I'd be mapping this over here. Let me quickly create a box plot for this, geom box plot, and let's see what would be the result. So here, as you see, we have created a box plot. So now this internet service would tell you that we've got three different categories. We've got one category which is DSL. So these are all of the subscribers who are using DSL as internet service. These are all of the customers who are using fiber optic as internet service, and these are all of the customers who are using or who are not using any internet service. So if you look at this box plot, you can clearly understand that those who do not have any internet service, right? So these are all of the customers who do not have internet service, and their monthly charges are extremely low. Now similarly, if I only look at this particular plot here, this is the minimum value, this is the maximum value, this is the median value. So this box plot tells me that the minimum monthly charges that a customer could get if he's using DSL is $25 or maybe 25 rupees. It could be anything. Similarly, over here, the maximum monthly charges that a customer could get if he's using DSL would be around $90. And here, let's say the median monthly charges of the customers who are using DSL would be around $60. Now similarly, if I look at this box plot, so here those customers who are using fiber optic as internet service, you can see that their monthly charges, the minimum monthly charge for them would be 70. The maximum for them would be around 110 probably, and the median for them would be around 90 or 95. So these are all of the inferences which you can draw from a box plot. And that is why box plot is also a very handy tool in terms of mathematics as well as visualization. So I hope everyone is clear with this. Mayflower is asking what is the coding console that you're using. So the coding console which I'm using is RStudio. So RStudio is an IDE for the programming language R. So there are a lot of consoles or IDEs for R, and the most preferred by all of the programmers is RStudio. So you can directly get this. And folks, we are actually left with a lot of topics, but seems like we are short on time. So what we'll do is whatever topics we are left with, we'll probably cover them in the next session. So thank you very much for attending. Thank you, for giving your 1 hour of time on a Saturday. And we'll meet again in our next session. And well, always have a great learning.